In this video, we're going to examine the graph of sine of x in order to figure out what the graph of the derivative f prime of x looks like. So one of the things we're going to do is we're going to put tangent lines at negative 2 pi, negative 3 pi over 2, and then every interval of pi over 2 after that. And we're going to see what we can estimate. So if we put in these tangent lines, notice we're going to have some horizontal tangent lines at the top of the curves, and we'll have some horizontal tangent lines at the bottoms. So we can put those in. So those are places where the slope of the tangent line is 0. And now notice that at negative 2 pi, it looks like it's going to have the same slope at z0, which makes sense because of the periodicity, and the same slope at 2 pi. Our job is going to be figuring out what those slopes are. Also, at negative pi, it looks like we're going to have the same slope as at pi. And because of the symmetry of the graph, it's probably just going to be the negative of our slope at negative 2 pi and 2 pi. Now, clearly, we can see it. All of these have a slope of 0. So we can just put that in real quick. Now it looks like, now remember this is about pi over 2 from here to here. So going from here to here looks like about 1 unit, and then it's going up 1. So it looks like a slope of 1 at negative 2 pi, 0, and 2 pi. And real similarly, it looks like a slope of negative 1 at pi and negative pi. So it looks like these have slopes of negative 1, and these have slopes of 1. And this guy here. Now, what we can do is use our definition of the derivative to see what's going on at 0 and calculate f prime of 0. So that's going to be the limit as h goes to 0 of sine of 0 plus h minus sine of 0 all over h, which simplifies to the limit as h approaches 0 of sine of h over h. Well, to figure out what that is, we're going to employ some help from our graphing calculator. I'm going to put this in as a graph so that I can use my table to use values that are close to 0, because if I use 0, I get an error. So maybe 0.1, 0.01, and 0.001. And on the negative side, negative 0.001, negative 0.01, and negative 0.1. It looks like we're getting close to 0. Notice there's some rounding going on by our calculator there. But it turns out this limit is going to be equal to 1, which confirms what we were seeing in our graph. And based on the periodicity, these are all going to be 1, and these will always be negative 1. So not only are our function values periodic, the slopes of the tangent lines are periodic as well. So let's see if we can get a graph going based on our slopes. So at negative 2 pi, we had a slope of 1. At negative 3 pi over 2, we had a slope of 0. At negative pi, we had a slope of negative 1. At negative pi over 2, we have a slope of 0. And at 0, we have a slope of 1. Now again, here comes our periodicity. Pi over 2, we have a slope of 0. Pi, we have a slope of negative 1. 3 pi over 2, we have a slope of 0. And at 2 pi, we have a slope of 1. And notice what graph we're going to have here. If we draw it with a nice smooth curve, we can see that we're going to get another wave function. And in fact, we are going to get cosine of x. It turns out the derivative of sine of x is cosine of x. While this is not a formal proof, it does use what we know about the function and the slope of the tangent line to show that the derivative of sine of x is cosine of x.